I am Prashant Nevaskar and I am in discussion today with my grandson Arman Nevaskar. I hope you have seen his Armanopedia season 1. We are now starting the season 2 and this is the first episode about Cosmos. This episode is for our young viewers, and to understand Cosmos they would like to know the meaning of different terms they encounter. So let us start with explaining the different terms. So let us first start with Big Bang.
Okay, so the Big Bang was the creation of the universe, not a heavy metal rock song. It was the creation of the universe. It started out as a small little particle, and it contained like all the matter that was necessary to create the universe. So then, basically, it exploded, and all of that matter over time formed all of those galaxies and stuff. And it took place about 14 billion years ago, a very long time.
Yeah. The second thing we want to talk about is nebula.
Okay, so nebula are, if I were to describe it in 2 words, stellar nurseries. It's where stars are born. So like all that gas and dust and particles is pulled in by gravity, and what happens is the hydrogen starts fusing into helium, and the gas and dust pulls in even more gas and dust, and it grows bigger and brighter and eventually creates a star.
Now let us talk about the solar system.
So, for the solar system, I have a sheet of paper that I will use to give a brief overview of all the planets. So, the planets got their names from Roman deities. Like Mercury was named after the messenger god, and it got that name because it's the fastest rotating planet. Both sides are polar opposite. One is in extreme cold, getting up to minus 430 degrees Fahrenheit, and the other can get blazing hot. Venus is the hottest planet there is, and is filled with dangerous clouds that can cloud your airway and kill you. And they trap a lot of heat. There's Earth, which hosts us, and then there is Mars, famous for, if people believe, it can host alien life. And Jupiter, which is the largest planet, and it's up to 142,984 kilometers wide. It's a gas planet and is said to even rain diamonds. Saturn is the planet with the most prominent rings of the gas planets. It's a really cool fact is one of its moons even has rings. And before we go on to Uranus, I just want to tell a fun fact about Jupiter. It has around 60 moons, and its 4 largest are Io, Callisto, Ganymede, and Europa. Now let's move on to Uranus. Uranus is famous for being tilted this way, while other planets are tilted that way. And it moves in a separate direction from all the other planets. And Neptune is the coldest planet and is filled with harsh winds. It's also the most distant from the sun, which is why it's the coldest planet. And finally, there's Pluto, a dwarf planet that's smaller than our moon, even though 3 orbit it. And it's probably the most famous of the dwarf planets. And also, I forgot to say Mercury's diameters, and since it's the smallest planet, that its diameter is 4,879 kilometers.
Okay, now move on to the next topic, galaxies.
So galaxies are basically large collections of stars, stars and planets, and we live in the Milky Way. I'm sure you've already known, and it's in about 4 billion years. Andromeda and Milky Way will combine, and basically like form an explosion. But don't worry, that's a long, long time away. And a fun fact is, did you know there are more galaxies in the universe than there are grains of sand on Earth? It's true. Crazy, right?
Now let us talk about the evolutionary process of stars. What happens to the stars when they come to the end of their life? So first of them is red giant.
Yeah, so stars basically like they live their incredibly long life, but then they keep like fusing like hydrogen, helium, carbon, and then it goes all the way to iron. And then iron basically it destabilizes the balance between radiation, and so the star becomes very cold, and heat and gravity, where the gravity increases majorly, and so it starts collapsing in on itself, pushing out its borders, and becoming a red giant. You would think this would make it hotter, but as I said, it actually makes it cooler the redder it gets. And it consumes all the inner planets, and then it will explode in a beautiful, explosion. Yeah.
Yeah. Basically, in a red giant, there is an inner core which gets denser, whereas the outer core expands and the star becomes much bigger. And since its density in the outer shell reduces a lot, so its temperature drops, and that's why it becomes red in color, right?
Yeah.
Okay. Now we move on to white dwarfs.
Yes, white dwarfs. So after it's exploded, whatever is left of it will make something known as a white dwarf. It's a very dense object that could be about the size of the Earth, and then after a white dwarf, it becomes a black dwarf.
Okay, now let us talk about neutron stars.
Yes, so neutron stars are basically so you see all these protons and electrons, they fuse together into neutrons, which become this like superfluid inside a crust. The superfluid inside the neutron star is so dense it would be equivalent to, like, say, putting, as Neil deGrasse Tyson put it, putting 1 million elephants inside a single thimble. That's how dense it is, and it's that small, and that's basically how dense it is. Another example would be, it's like compressing Mount Everest and its density to the size of a sugar cube. So neutron stars have the greatest magnetic field in the universe, right?
Yes.
And they're incredibly fast. The fastest rotation speed of a neutron star ever recorded was 700 spins per second. And since it's so fast, it emits these beams that are like, which are sort of like lighthouse beacons. Right?
Yeah, it has a very strong magnetic field, and rotating at such a fast speed, it gives us, like a lighthouse kind of thing.
Yeah.
A rotating beam, and this was first observed in 1967 by Jocelyn Bell, right?
Yes.
And that is when the neutron stars were discovered.
Yeah. And so all of that, it's releasing electromagnetic radiation, and it's like pulsing, which is what is called a pulsar.
Pulsars.
And eventually its electromagnetic and gamma waves basically cause it to die off, and eventually it will collapse. There are two other forms of a neutron star dying, though. So a neutron star could also die by sucking in like another star's life force. Of course, stars don't really live, but like it basically orbits another star that's bigger but less dense than it, and sucks in its atmosphere and consumes it, and then explodes, becoming a black dwarf. Basically, it goes out with a bang. And the final form is incredibly rare. It's when two of these neutron stars circle each other, and they go so fast they cancel each other out and explode.
Okay, now the last topic of today is black holes, a very fascinating topic.
Yeah, so black holes is not a heavy metal band, but it's an actual thing. So basically, when all these, like when a star dies, generally a very large one, it creates a black hole. Or as I said, when a neutron star and another star collide, it becomes a black hole. So the only visible part of a black hole is its event horizon, and so that event horizon is the only thing you see before you're sucked into inky blackness.
So
not even light can escape its great gravitational force.
Yeah. So event horizon is basically boundary of a black hole.
Yeah. And another thing is.
And what is in the core, in the center of black hole? It is singularity, right?
Yes. And black holes are basically incredibly cold. You think the Antarctica is cold? You've never been in a black hole, and hopefully you never will. And so, black holes, their gravitational pull, as I said, is able to not even light can escape. And since it's at right now impossible to exceed the speeds of light, if you came across a black hole and were traveling like right in front of it, you wouldn't ever be able to get out. Would you like to explain how the black hole got its namesake?
Yeah. So in 1784, John Michell, a British clergy and astronomer, he first thought about the black holes, but he called it dark star. And it's only in 1960s when Robert Dicke first coined the term black hole, and it was a simile to prison in Calcutta, which the anecdotes say that if the inmates went in, nobody came out. So that's why in black holes, when any mass enters, it will never come out. So that's why the simile, but this term caught on and became popular.
And one more thing. So there's an actual way to destroy them. Thanks to astrophysics genius Stephen Hawking, rest in peace. We now know there is a way to actually destroy black holes. See, two different particles, when they collide, they cancel each other out and destroy each other. If both particles like that come at the event horizon, one will be expelled outwards, one will go inwards. And the one that goes in will find a one that's like the one that was expelled outward. They will collide, and that will very, very slowly decrease the size of the black hole. And for black holes like the largest one there is, which is about 400 million times the mass of the sun, it will probably be the last thing this universe will ever see.
So basically, the Hawking radiation slowly dissipates the black hole.
Thank you for watching. Subscribe. Tell me what you think in the comments below, of course. And give it a like or dislike. Thank you for listening to this interview, and I hope you have a good day.
And thanks, Arman, for speaking to your viewers. Well done.